Okay, good evening everyone. Before I start with the lecture, where we continue what we've done yesterday with business intelligence, I want to bring you up to speed about the midterm tests. So, if you are on Learn, if you come down to the link that says Pass Tests and Exams, what I've done over the weekend is put up a Word document called Midterm Test 2022 Review Questions. I'm just going to show you what that document looks like, but I'll talk to you a little bit more about that document in week 6. So, your midterm test is scheduled for the 31st of March up to the 1st of April between 6 p.m. and 6 p.m. This is also 6 p.m. Overseas. I know some of you are going to be taking the midterm test while you are out of New Zealand, and that's fine. So the link, your exam paper, your test paper will be available for a 24-hour period. But once you download the midterm test paper, you have 2 hours to complete it and upload your answers on Learn. So the details of the starting time is 6 p.m. on the 31st of March. That is a Thursday, the 31st of March. Your last discussion tutorial on Thursday finishes at 1 p.m. So plenty of time between 1 p.m. till 6 p.m. on the 1st of April. I've also told your discussion tutors to make the recording available on Thursday. As soon as the last discussion tutorial is over, the recording of that tutorial will be made available on Learn, so you will have access to that recording before the start of the midterm test. So, you have 5 questions. Each question will be worth 10 marks, and you will get a question from every single chapter that we have done in class, starting from week 2. So the stuff that we did in week 1 will not be assessed. We start the assessment with hardware, software, and mobile systems and networks, and we will continue this until week 5 when I do enterprise systems. So in week 5, when we do the lecture on Monday, I will finish the lecture on enterprise systems because that's a relatively short lecture. When I see you on Tuesday, week 6, we will do the revision, which means we'll go through the questions you see in this document, and we'll try and attempt to answer the questions and a little bit of guidelines in relation to what you should write in the test paper and what you shouldn't write in the test paper. So the midterm test is online and open book, which means you are free to refer to any source that you want in order for you to write or help develop an answer. But it doesn't mean cut everything you see on the internet or on the slides and paste it in your answer script, because we will run your exam scripts answers over Turnitin, and if we find similarity or suspicious, we suspect that plagiarism has gone on, then we will pull your exam paper out and then call you in for a discussion and meeting. The only thing you cannot do is talk to another human being about the test questions or the test answers throughout the duration of 6 p.m. 31st March up to 6 p.m. on the 1st of April. But you can look at the notes, look in the book, Google the internet and try and see if you can locate some answers. But let me tell you, if you spend too much time doing that, you're not going to be able to answer the questions. You should be able to attempt the questions on your own, because you would have enough knowledge by the time you reach week 6 in order for you to be able to answer the questions on your own. You don't need to refer to the slides, don't need to refer to the books. If you've been paying attention in class and participating in the discussion tutorials, you would have no problems whatsoever. Now, the other thing that I want to let you know is when you write your answers in the exam, you will have a requirement in relation to the limit on the number of sentences that you can use. So in this question here, you have a limit of 4 sentences. So this is what you're going to have to train yourself to do slowly. Try and get to the point as quickly as possible by limiting the number of sentences that you use to answer the question, because When we have a limit, we do this because it is open book. Otherwise, we might get a whole page answer for something that's only worth 4 marks and you've just wasted your time. So we put the limit on the number of sentences to guide you as to how much you should write, and usually the limit on the number of sentences will also be associated to the marks for each question. So very quickly, with question 2a, you're asked, what are application programs and what are operating systems? And you see the mark allocation here being 4, which means you're going to get 2 marks for application programs and you're going to get 2 marks for operating systems if you answer it correctly. And we have provided you with 2 sentences to explain what application programs are and another 2 sentences to explain what operating systems are, and that is how you limit your answer to 4 sentences only. So get into the habit from today when you do your discussion tutorials to try and get to the point, limit your sentences to what the question wants, and there's no need to talk about anything else other than that. So I will leave you with this document. You're welcome to take a look at it over the weekend and over the next few weeks. I will go through this document with you again when we do the revision session on Tuesday, week 6. Everybody okay with that midterm test? Any questions? Anything at all that you need which I haven't? Yes?
Is there like a practice test?
Yes, this is kind of like a sample test trial, if you like, which you could attempt, which will kind of tell you what you should be studying for the test. So I've got questions from week 2 right up to week 5. So take a look at the questions and that kind of gives you an idea of how to prepare. Yes?
Do we need to write the max number of sentences that they
No, there is no need. The maximum there just tells you that's the maximum. But if you feel you're able to express your answer in less than 4 sentences, go ahead and do it. That's fine. We're just telling you that's the limit, and the examiner will not read any more than 4. Yes?
In the actual quiz, will it say how many marks each question's worth?
In the exam, in the real test, yes. You will have the question and I will have the marks associated to it, and I will slowly teach you how to relate the breakdown of marks. So in this example, it's quite clear, 2 and 2, because you've got 2 questions, and you will also see the same in the real test paper. Was there a question? Was there a question? Okay. Anyone else? Do you need anything else from me to prepare for the midterm test? We are 2 weeks ahead of time. This is week 4. Your midterm test is only in week 6, but I'm preparing you from now, because week 6 is also when we release the Excel assignment. So you've got 2 things to worry about for INFO123. 3 things to worry about if you're doing a presentation in week 6. So those of you doing a presentation in week 6, you've got 3 things to think about. Okay, so we'll come back and look at this document in week 6. I'm happy for you to look at it. It's already available on Learn. And if you have any questions in relation to that document, feel free to send me an email and ask. Okay, so we left off with RFM analysis. Okay, one more piece of announcement. You would have seen Angela's message on Learn. All the presentations now are going to be online over Zoom. That's just to accommodate all the isolation that will happen in the next few weeks. So we're just going to standardize that over Zoom. Now the other piece of advice is in relation to your PowerPoint presentation. Some of you are doing this topic called identity theft. That's fine, nothing wrong with that topic. And some of you have given me a structure or outline of how, on what you are going to present. Be very careful and think about ethical issues when you touch on a topic like identity theft. There is no advantage of identity theft. The culprit who has performed that activity, it is not to his advantage. Neither is there an advantage to a person suffering from identity theft. So can you please be a little bit ethical in your thinking, and when you're approaching subjects like security or identity theft in this case, there are things you don't talk about. It's not right to talk about the advantages of being being a subject of identity theft, or if you're the person launching an identity theft activity. So just be careful around those areas when you're looking at it. I know advantages and disadvantages would be something standard most groups would cover, but sometimes in certain topics you cannot cover advantages and disadvantages. Okay, back to recency, frequency, and monetary value. This is an example algorithm that you could use if you are interested in coming up with basic reporting. So recency basically stands for how recent has the customer purchased from you. Frequency, how often does the customer come into your store on a weekly basis or on a monthly basis. And money relates to how much a customer has spent in your store buying up your products and services. So when you look at RFM analysis, you will be typically given a table like so. In that table, you would have a list of your customers, and you will have the alphabets R, F, and N associated to each customer. So remember, how recent has the customer come into your store, how frequently is he visiting or she visiting, or the company visiting your store, and how much money has this customer now spent in your store. In this table, you only see 4 customers. In real life, you might have 5,000 customers. So this table is going to get very, very big and very, very large. When you provide numbers inside that table, that numbers usually stand for something. In this example, number 1 means the top 20%, number 5 means the bottom 20%. If you read this table, it means Ajax was one of the top 20% customers who had recently arrived in your store. Ajax was also one of the top 20% customer who had always frequented your store over the month. However, Ajax is not the top 20% when it comes to the amount of money spent in your store. And that's how you would go about reading this table. I'm going to pick another one for discussion. Bloomingham's, 5 for recency, 1 for frequency, and 1 for monetary value, which means Bloomingham's was only the bottom 20% when it came to recency, had not come into your store in the recent few months. However, when Bloomingham's was recent, that is an organization that bought from you very frequently, top 20%. And when that organization bought from you very frequently, that organization also spent a lot of money in your organization buying products, the top 20%. Can you see how you now read that table using those numbers and understand what recency, frequency, and monetary value mean? Now, this is data that you will now store inside your data warehouse. And you will now pull different aspects of this data together, which is recency, frequency, and monetary value. And perhaps the marketing department would now like to look at the data in order for them to make sense of what they're seeing. So one way for you to make sense of the data that's sitting inside your data warehouse is to perform something simple like this called RFM analysis. The marketing department now would ask the question, what can we do with Ajax and Bloomingham's and Caruthers and Davidson? How do we entice them to buy more or come more frequently or visit us more often? This is the questions you ask because you are now trying to do prediction. You know what is. The table tells you the what is the current situation. That is the current situation. That is what your customers' purchasing and buying behavior is like. How are you going to make sense of that table? Get the marketing department involved, and you ask the marketing department, that's your historical information about your data, your customers, which I have now found from my data warehouse. What are you going to do about it? So the question that I have here is, what action can you now take for each of those companies? And sometimes you might decide, the marketing department or the management department might decide to say, hang on, for some of these guys that you're looking at here, I don't think there is any need for us to do anything because it's going to be pointless. So if you were in the marketing department and you have now been asked, what suggestion would you make for Ajax? 1 for recency, 1 for frequency, but only 3 when it came to the amount of money spent in the organization. Someone in the marketing department may say, how can I entice the customer Ajax to spend more? Because this is an organization that's already coming to me very frequently, and it's also had a very recent visit to the organization, but this is not an organization that's spending very much. Not even the top 20%, not even the top 40%, only within the top 60%, and that's not good enough. What can we offer Ajax so that Ajax will now buy more from us? Might think about offering discount vouchers, might think about doing a buying in bulk discount. So this is what the marketing department looks at from your business analytics and decides, what am I going to do? Sometimes you may look at certain customers like Davidson, who's got 3 through R, F, and M, and the management may decide, is this going to be worth our while to offer Davidson any kind of enticement to buy more, visit us more frequently, or come to our stores often? And management may decide, perhaps there's actually nothing we can do here with Davidson, because Davidson is 3, 3, and 3. Therefore, if we even think about doing anything, it might be wasted effort, and we are better off spending more time with Bloomingham's, which is a 5 for recency, but 1 and 1 when it came to frequency and monetary value. So this is how you make sense of the data. RFM analysis is an example of how you would use basic reporting analytics to provide to your organization, and the organization says, this is what we can do, this is what we cannot do. You can also extend RFM analysis to include products bought, and with that dimension, you can now know, how can I sell something with the product that Ajax always buys? Let's assume Ajax always buys paint, and you know this from your data warehouse because you have stored this information inside your data warehouse. And so the marketing department might decide, Ajax is always coming into my store to buy paint. What can I get Ajax to buy paint with? Paintbrush, roller brush, drop cloth. And so you're now providing Ajax with a little bit more options to say, are you now interested to buy a roller brush? Are you now interested to buy a paintbrush? Are you now interested to buy a drop cloth? Remember, you can only do this if you have big data like that. And you can only do this when you have a data warehouse. And you can only do this if every department in your organization is asking the question, what can we do with this data? What is this data telling us? Sometimes you might need to think about, should we even bother doing anything if there is no point or if it's not worthwhile for us doing so? The third method of basic reporting is called online analytical processing, OLAP for short. OLAP is made up of multiple dimensions of storage, and in this case you would see the various areas. You would look at the type of products on the other dimension, and on the third dimension you have quarters of each year. OLAP is very unique because it allows you to perform an activity called slicing and dicing. Sometimes in some books you would see the word drilling across, meaning generalized information, drilling up, some kind of generalized information, and drill down, where you're able now to see detailed information. The whole activity of slicing and dicing basically means you do not need to look at the entire data warehouse. You can pick and choose dimensions that you are interested in and only perform analysis on those dimensions. So on the example that I have on my left, I'm only interested in Q2 sales of 2012. Not interested in anything else. In the other dimension that I have, I'm only interested in desktop sales across the year 2012 for the West Coast division. Not interested in the North or the South or the East, neither am I interested in any other type of product. OLAP provides you this online interactive method of looking up a data warehouse and only providing you the information that you want, instead of providing you with a full-fledged view of the data warehouse. Now, when you run OLAP, this is what you get. These are reports that are dynamic, so you don't need to make any change inside the data warehouse. You don't have to make any change anywhere. You just run the query, you run the analytics tool, or you run the algorithm, and you simply say, I'm only interested in desktops for the first quarter of 2012, and that is it. So this is what we call drill across, summarized high-level information. What you're looking at here is different type of stores and the amount of money that they sell in the amount of products that are drink products and food products and non-consumable products that they have sold across the various different stores. So very high level, very generalized. In this diagram, what you're looking at is drilling across. I'm still looking at food, I'm still looking at drinks, and I'm still looking at non-consumables, but this time I'm looking at specific stores in specific states in the United States: California, Oregon, Washington. The last diagram is when you drill down, when you want specific information. You want to look at as much detail as possible. You are not interested in high-level generalized information anymore. When you drill down, you now look at specific stores in a specific state. So in California, you're looking at the city Los Angeles, San Diego, San Francisco, and Beverly Hills. When you are looking at this type of information, this is what you ask yourself. Why are certain stores selling a lot of drinks and food and non-consumables? Why are the other stores selling less of it? Is there a particular reason? And then the operations management people in your organization might decide, if there are certain stores that are not selling lots of drinks and lots of food, why are we sending them lots of drinks and lots of food? What can we change in our supply chain so that we don't overwhelm certain stores which don't sell too much food or don't sell too much drinks? And then you have to ask yourself, for the stores that sell a lot of drinks and food, can we provide them with more drinks and food? Do they have the warehouse or the storage capacity and capabilities to store this? And this is the business decision-making questions that you ask yourself when you have data like this presented to you. So this is OLAP. It is interactive. You can slice and dice. You have the option of drilling up, down, across, and viewing information any way you want, so that you now know what's happening in your stores, and you now know what the inflow and outflow of drinks, food, and consumables look like in each store. Some business managers may look at this and say, perhaps it's time to now close down some of our non-performing stores because we're simply not making profit and there is no need for us to keep those stores in operation. Business question. It's a business decision that you now have to make based on informed data. Evidence-based decision making. This is your evidence. You make the decision. Business analytics cannot make the decision for you. All it can do is provide you all the data that you need so that you can now make that decision by yourself. When you run OLAP, it's nice to see things in pictorial format or in pie charts or in graph bars. And that is a technique that we call data visualization. Because the people making decisions don't have time to read 50-page reports. Neither do they have time to look at this in this format and decide what they're going to do with certain stores and what are they going to do with their supply chain. So dashboards is basically a word where we have adapted from the car dashboard, where you get to see the important elements about the health and well-being and the state of your car. Does it have enough petrol? Is it heating up? What speed are you driving at? Is your handbrake still on? So the important information that you have on the dashboard of your car is also the same adaptation on the dashboard of a business intelligence tool. I want to show you what's important in the fastest and easiest and most effective way for you to understand. And one example application that allows you to do this is this application called Tableau. Slice and dice, pick up what you're interested to see, and it's shown to you in the best visual format way possible. It might be a plotter graph like that, it might be in a pie chart, it might be in a graph bar. Remember, this is all interactive, this is all online. It is a drag and drop activity that can only work if you have a warehouse, if you have your right data sources, and if you have performed your ETL processes. Now, aside from basic data reporting, we have the more technical and advanced method called data mining. Data mining is when you actually now have to hire a programmer who is sometimes a statistician, an expert, to look at the data that you have sitting in your warehouse and write codes for you to make sense of the data that you have sitting, so that the accounting department can decide, do I want to offer a customer credit? Is this customer a good payer? Can I think of providing discounts to a different customer who has bought from me very often? The first type of data mining technique is called supervised. So there are only two types. You either have supervised data mining or you have unsupervised data mining. Supervised data mining means you kind of already know something about the data that you have stored inside your data warehouse. So to illustrate how supervised data mining works, I'm going to use this tray of fruits. Think of the time when you were a lot younger, and how did people teach you to recognize fruits? Some of you may be taught to recognize fruits based on shape, size, color, texture, taste, and therefore you have now come up with different categories in order for you to categorize fruits. When we look at data mining, we use the term data sets. We don't say data warehouse, we don't say database. We use the term data set specifically because we are storing very specific items about our interests. In this case, I'm only storing pictures of fruits and nothing else. But I do not need to classify those fruits into primary key, secondary, and attributes, because it's simply not possible for us to do this, because fruits is unstructured data. There is no way for you to organize them in a structured manner. So you already know something about your data set. You are looking at pictures of fruits. And because this is supervised data mining, you already know something about fruits. So when you are given this bowl of fruits, you may look at it and say, I have got fruits here of different sizes, different shapes, and different colors. And therefore, I will now use those three categories or those three criterias to now start putting or filling up the requirements for those fruits. So you would pick up a fruit and ask yourself, is it big or small? What color is it? red or green. What shape is it? Is it heart-shaped? Is it long and curvy, cylindrical? Is it round-shaped with a depression on the top? And then you tick off things. If it's big, red. Round-shaped with a depression on the top, it is now an apple. Then you pick up the next fruit and you ask yourself, what color is it? What shape is it? What size is it? And then you classify that fruit into apple, banana, grapes, so on, so forth. Sometimes with supervised data mining, because we always know something about the data that's being stored in our data set, it becomes a little bit easy for us to decide how to write our algorithms. Another example of supervised data mining is an algorithm called regression analysis. In this example, you want to try and predict cell phone weekend minutes. You want to see if you can accurately predict how much time is one of your customers going to spend on the phone over the weekend. And so when we provide the data set to this statistician, the statistician looks at all the possible attributes that you have collected about your customer. Age, income, education level, occupation, whether it is a prepaid phone or a postpaid phone. Is it a phone on contract? Is it a phone not on contract? And the regression analysis algorithm automatically mines the data set and comes up with an algorithm to say, if you want to accurately predict weekend minutes, that's the formula you use. You take the number of months this person has been a customer with you, you divide that with a number, and then you take the customer age and you divide that with a number, you add them up together, and again with 12, and that is how you can now predict weekend minutes of a specific customer. Remember, you don't do this, the algorithm does this for you, and all you need to do is use that formula and run that formula across all the customers that you have in order for you to predict weekend minutes. Why might Vodafone or Spark be interested in predicting weekend minutes? You might want to think of providing them the high-end user usage with some discount. You might want to think of reducing prices over the weekend. Somebody in the organization may say, hang on, I'm also interested in data consumption over the weekend. Can you now come up with an algorithm to tell me which of my 1,000 customers would be high users of data consumption? Can I now offer them a specific plan over the weekend so they don't pay too much? Which of my customers are low consumption users of data over the weekend, and can I now encourage them to spend more money on data over the weekend by providing with some extra credits? So IT and IS can do the back leg for you, the work in the back office. Well, once you present this data, it is a human being that now needs to make sense of that data and decide what are you going to do with that data. The other type of data mining technique is called unsupervised data mining. So remember, supervised means you know something about the data set. It's going to be pictures of images. When we use unsupervised data mining, it means we know nothing about the data set that has been presented to us. So you have to learn from scratch as to how are you now going to categorize this bowl of fruits, because you now know nothing about size, nothing about shape, and nothing about color. One way how an algorithm might go about classifying this bowl of fruits via unsupervised data mining is, how many fruits do I see of the same color? 2, 3. It looks like red is a popular color in those in that bowl of fruits, so I'm going to now use red as a classifying criteria. Of the fruits that I see that are red, some are red and yellow, some are plain red, and therefore you might come up with a second classification criteria to say red only, red and green. And then you might look at this bowl of fruits and say, I also see some fruits that are green, and therefore green now becomes the next criteria. You might look and see some of the green ones are round, and some of the green ones are also looking a little bit cylindrical. And so you would have your third criteria and your fourth criteria, and you now have your criterias one at a time, and you merge the criterias as you come across those criterias. The problem with the data set is it is good if you have standard images and pictures and photos of fruits inserted into them. But once you introduce a fruit that doesn't fit the criteria of red, red and big, red and small, green and big, or green and small, that's when your data set now says, sorry, I'm not able to classify this fruit because I do not have a criteria that is now going to fit the fruit called the lychee. So your data set is going to be as good as you train it to be. If you train your data set with 5 pictures and 5 pictures only, it is not a well-trained data set. If you train your data set with 5,000 pictures and variety of pictures, then we usually say it's a well-trained data set. So the algorithm can only do so much. Sometimes the algorithm is dependent on how well-trained your data set is. So that's your supervised data mining. When we look at data mining techniques, because they rely on a concept called machine learning, there are some issues that you're going to be have to be aware about. If I were to insert these 4 pictures into my data set, and I call them chairs, I might look for ways to classify them as chairs. I might say it would need to have 4 legs. It would need to have a flat horizontal surface for someone to sit on. I might need a flat vertical surface so that someone can rest the back on the backrest. And I would then tell the algorithm, if you have a flat vertical surface, horizontal surface, and 4 legs coming down from the bottom of the horizontal surface, it is now a chair. To the human being, that's a chair. You have now trained your data set via machine learning to understand and accurately predict that if you see an image that looks like that, it is also going to be a chair. But then when you insert these images into your data set, that is when you start to have problems, because there are now 4 legs, there is no vertical surface, flat surface, there is also no horizontal surface. So how are you now going to tell your data mining algorithm that these are also chairs, but they don't fit your standard criteria of a chair? To a human being, you look at this and one glance, you know, I don't need to understand the concept of 4 legs, flat surface, horizontal, vertical. I know that this is a chair. But how do you now teach the machine learning algorithm that these are chairs? You can't, because your classification says 4 legs, flat vertical surface, and horizontal surface. And this is when you have pictures like this inside a data set, it will simply come out with undefined, unable to classify. And you might think that your algorithm is bad. Not necessary. Sometimes your data set has been populated with non-standard images of a chair, and therefore now you have a recognition problem. You cannot recognize that these are chairs. This problem is slightly compounded when you rotate the chair 90 degrees to the left, 180 degrees to the right, because then your standard criteria of 4 legs, flat surface, horizontal surface also goes out the window. So these are some issues with machine learning which we haven't yet solved, and this is why sometimes when you try and use Google Images and say, give me a picture of a fish, you might get a fish. You might also get a lot of rubbish along with the fish. Okay? So supervised data mining, unsupervised data mining. Unsupervised, you know nothing about your data set. You have no prior knowledge, you do not know how to classify, and you have to start from the very, very beginning. Another example of unsupervised data mining is a simpler concept called decision trees. I'll show you what the decision tree looks like first. That's what a decision tree looks like. And then I'll explain to you how this works. Let's assume the university is now trying to come up with a prediction criteria to say which of my 1,000 students enrolled in a Bachelor of Commerce program will get a grade of greater than B for INFO123, and which ones of my students will get a grade of less than B. So what I will do with the decision tree is I will put all my students in the big large circle that you see up front. And I will collect as much information as I can based on the attributes of my students to decide how best can I come up with classification criteria to predict the grade of a student. So I will collect as many attributes as I can about my 1,000 students, from age to gender to high school to NCEA results to if you are working part-time, if you're working full-time, if you're a first-year student, final-year student, so on, so forth. And I dump all that into my data set. The decision tree algorithm looks at all my attributes and starts classifying my attributes in order for me to be able to predict the grade. So in this example, and this is a hypothetical example, I've put all my students in the large circle that you see right on top, and the decision tree algorithm tells me the first criteria that is able to very clearly distinguish if my students are going to get a grade of B or greater or less than that is the year of study. And so decision tree says first criteria, year of study. If you're a second-year student and if you're a third-year student, that becomes a criteria. It is irrelevant if you are a first-year student because I cannot predict anything if you are a first year. So I will now put all my students either into second year or third year, and if I have students in the first year, I will simply omit them because the algorithm tells me that that is not a suitable attribute. Within the second year students, the algorithm now further does classification and tells me if a second year student is working in a restaurant and if this second year student is not a restaurant employee, that is a good criteria for me to use to distinguish you. If you are a third year student, it will depend on your major. If you are a business major, there is a likelihood of me being able to predict your grade. If you are a non-business major, there is also likelihood for me to predict your grade. And so what I've done now is populated my large data set of students into the smaller criteria, into the circles, and then into the second criteria, which is, are you working in a restaurant? Are you not working in a restaurant for second year students? And if you're a business major or non-business major, if you're a third year student. And I populate the number of students in the large circles. So the white small circles are students that will get a grade of greater than B+, and the orange circles are the number of students that will end up getting a grade of less than B+. And so the decision tree is now developed based on a set of criteria fed into the decision tree algorithm, and this is the outcome. This is the output of the decision tree. You now look at the decision tree and you have to come up with something called if-then statements, your prediction. This is something you are going to have to do by yourself because the decision tree stops here and says, these are my criteria, best effort, these are the most distinct criteria that I can come up with. You're now going to have to look at those circles and decide greater than B+ or not greater than B+. So you always look at the circle right at the bottom and you look at the number of orange small circles and white small circles. If you're a second year student and you are a restaurant employee, the likelihood of you getting a grade of greater than B+ is high because the decision tree algorithm has got more white small dots in comparison to orange dots. And then, if you're a second-year student and a non-restaurant employee, the likelihood of you getting a grade of less than B plus is very high because you have more orange dots here in comparison to white dots. But if you move over this side, with my third-year students, if they are doing a business major, I cannot accurately predict the grade because it appears that there are equal number of white dots and orange dots, which means if you are now a third-year student and if you are a business major, I'm not able to predict if you are now going to get a grade of greater than B plus or not. And then you come up with your if-then-else statements based on your decision tree, and that is how you go about making your prediction. So, you've been exposed to a lot of algorithms and different ways for you to decide to run business intelligence tools. The outcome is up to you. Your organization will dictate the options, the tools, and the algorithms that you want to run. It can only provide you with the data. You have to now make sense of that data and decide what you want to do. When I see you next week, we will do a non-ITIS subject. We will do a slightly business-orientated subject that's called business process modeling or engineering. So I'm happy to take any questions if you have any. Otherwise, you have a great rest of the week. Get prepared for the test and the presentation and the Excel assignment. Thank you for your attention. Thank you. Thank you.
Hi. I was emailing you about practicing the.
What is your name?
Richard.
Oh, yes.
So that's tomorrow?
Yes, but I'll send you. Did you see my email?
Did you send me another one?
Yeah, I'm not able to do this, Richard. There's something that came up which required me to now go to the city. Are you able to record the presentation and then send it to me?
Yeah, we should.
Email?
And then since we're doing it on Zoom anyway.
Yeah, probably makes sense for you to record it,
better,
right?
right?
Yeah.
Okay,
Yeah,
sweet.
so record it and send it to me. Thanks. I'm sorry about that.
That's all right. Can I see the video by
Yes, you can.
So now that it's on Zoom, what is it sort of going to look like? Are we going to have to be like in the same room over a Zoom call?
That's up to the group if you want to all be in the same room.
I'm just not used to Zoom. I don't think I've really used it before, so I'm.
Oh well, this is your chance to practice it on
Yeah.
Zoom then. So either all of you in the same room or in separate locations, it's fine.
Oh, okay. One of these.
Yeah.
Hi, for the decision tree, is there not issues with like confounding variables and causation and correlation with say the if and then statements?
Yes, that's true. So
So-
that's something that that's a decision that the organization will need to make.
Okay, so do they need to deal with that like outside of the
Yes,
algorithm
outside
itself?
of this. Yeah.
Okay, so if the algorithm gives that kind of classification, then it's up to the people to like see if
Further
there's
investigate.
confounding variables and
Yeah.
such. Okay, thank you.
Hello.
That group presentation, we have a group member with his like on the Facebook page, and he replied to us that he's done like nothing. So if he doesn't end up doing anything, does it matter?
Yeah, of course. Can you?
We've spoken to him because like he didn't reply to us. I seen him like the other day, and I was like, "You can do it with us." He's like, "Yeah."
So I think what you do is you send him a message over Facebook and you ask him, you're not going to do anything, you're going to do it without him.
Okay, sweet. So if he doesn't reply, we just.
Then you go, yeah, you've told, given the notice, you've told him what you
All right,
said.
sweet. Thank
Yep.
you.
Hello? Oh, just finished. Are you going to use the room? Oh, okay.
up Monday, something like that. What do you got around Monday?
Monday. Yeah, anytime.
I don't see that. Tuesday, 2:10. Yep. Was it well then? Yeah, yes. Alright.
Oh, so are we going, I reckon we just do intro after this one. What do you think?
You think?
Okay,
It's
well,
easy.
have you guys started?
No, I'm studying.
I reckon like, this is, since you
Like, we're looking at AI.
Yeah.
it's like, so, like me and Jack, like, well, we'll do it at the big top. But like, we'll either do like the conclusion or intro, like, and advantage.
The issue is, there's not that much of disadvantages, like,
You can't
they
do
can
that.
make
There's a lot of ethical kind of shit.
True, yeah, we could do
Yeah, like road, like the amount of road rule changes and service and stuff. Like,
Yeah, true, we could do that. Would you,
I mean, I think, yeah, I'm pretty cool with like tricks. I think he's doing a good intro.
You guys,
So I'll take anything really.
yeah, I'm all right.
yeah, what do you want advantage to the process?
I can take this one.
You can be an equal man.
Oh, yeah.
We can, we'll decide.
Yes, like, yeah, figure out.
Advantages and conclusion. Yeah.
Yeah, because it won't be too hard swinging from each one either, because it's just like intro, and we go into advantages, and then you get.
So I reckon we just like do a bit of our own research and maybe write a few notes down and then, like, I reckon it's easier just to meet up on Monday and spend like half an hour making slides.
Because I finished on like Monday at 1 o'clock, so I'm like free for
Are you free Monday at all?
Really, but.
We'll see.
Keep in touch then.
Yeah, good. At least we've got time sorted.
Yeah, that's the main thing really.
Doesn't seem like much more.
Oh yeah, minute and a half to 2 minutes speech, like.
Yeah, because it feels like I'll search up, it's like 150 words per minute, like that's nothing.
That's
Like it's a paragraph.
Like, yeah.
Like it's not much.